Okay, here it goes. I'm going to start out by just throwing a question your way. We know what the area is. We know how to find the area of a rectangle. My question to you is, and I'll admit that this is a borderline trick question at this point, but I don't want to give too much away. My question to you is, we have this rectangle here that is 6 yards by 2 yards, and my question is, how many square feet are there in that rectangle? If we were going to say the area of that rectangle in square feet, how many would it be? I'm not doing a poll, I'm just asking, and this is extremely low stakes. That's funny, Lorraine, but it's not what I'm after. I like it, but if we were going to say the number of square feet that were in this rectangle, how many would that be? And we've got some converting to do, um, but I'm curious what y'all will come up with on this one. And if it's still early and your brain's not really functioning fast enough yet, I don't mind diving into this one for us. Here's what I would not want you to do here. What I would not want you to do would be to say, well, 6 yards by 2 yards. I know that the area of a rectangle is length times width. So this would be 12 square yards. So far, we haven't done anything wrong. Here's where the wrong part comes in. Sure, it's 12 square yards, and I know there's 3 feet in a yard, so I'll take those 12 square yards, multiply by 3, and say that that's 36 square yards. And that all feels perfectly fine. The problem is it's not correct. So let's get rid of all that. So instead of 36 square yards, what we want to do here is, if we were asked for the number of square feet that are in this rectangle, first we're going to go ahead and change these 6 yards, multiply by 3, that'd be 18 feet. And 2 yards, multiply by 3, that would be 6 feet. And now that we know we've got a rectangle that is 18 feet by 6 feet, now we can find the area in square feet. And we're going to multiply 18 times 6. And when we do that, we get the correct answer here. 18 times 6 is 108 square feet. The reason that doing 6 yards times 2 yards and getting 12 square yards and multiplying by 3 gives us the wrong answer is because actually what we've had to do here is multiply by 3 twice. Multiplying by 3 once didn't do the job. Multiplying by 3 twice did. And so if we were going to change this to square feet, we want to make sure we change both the length to feet and the width to feet. Then we can multiply and figure out the number of square feet. Something else that might seem obvious at first, but our instinct may not be pointing us in the right direction. You have a square that is 4 centimeters by 4 centimeters, and you want to double the area. What will the side lengths of the new square be? If you want to throw out a guess, you're welcome to. I'm going to draw a picture of my 4 by 4, and I guess these are centimeters. I'll go ahead and label that. 4 centimeters by 4 centimeters square. If I want to double the area of that, what will the side lengths of my new square be? And if I didn't really think about this much, if I didn't really put a whole lot of thought into it, what I might say is, well, if I want to double the area, then I'm just going to go 8 by 8. Let's see if this worked. All right, well, in the square on the left there, my original 4 centimeter by 4 centimeter square, the area would be 4 times 4 or 16 square centimeters. In this one I drew over here on the right, if I find the area of that, 8 centimeters times 8 centimeters is 64 centimeters squared. Now, that's no good. That didn't work. I didn't double the area. Instead, I actually multiplied it by 4. If you think about how that happened there, we doubled this one, we multiplied it by 2. We doubled this one, we multiplied it by 2. So we've doubled our area by 4. That's not what we were trying to do. We wanted to double the area. So instead of trying to do something like this where we just, I'll just double the side lengths. That ought to do it. And if you're thinking, well, what if I make it 8x4? That's actually a decent thought. You might say, okay, well then I'll just make my new square 8x4. That'll have an area of 32. Why is that no good? It's not a square. Perfect, Lorraine. It's not a square. That didn't work. So instead, what I've got to do is actually go through something of a process here to figure out the side lengths of the new square. Okay, my square that I started with over here has an area of 16 square centimeters. If I want to double the area, then whatever the dimensions of my new square are going to be, the area's got to be 32 square centimeters. I want to double it. Now, I don't know what the length and width of this new square are going to be, but because it's a square, I know they'll be the same. Whatever the length is, the width will be the same. So I'm going to call those both x. Well, what that does for me then is if I wanted to calculate this area, length times width, x times x, I have x times x has to be 32. Or x squared has to be 32. And if we've seen, I can't get the word out. As we have seen before, if we want to make squaring go away, we're going to square root on the left, square root on the right. Those will cancel. I have just an x remaining on the left, and I get whatever the square root of 32 is on the right. I'll go ahead and write that down. We've got 5.6568, and that keeps going. Let's say we round that to the nearest hundredth, just because. So we go to the hundredths place with one space to the right. That's 5 or bigger. So our new side length is going to have to be 5.66 centimeters if we're going to double the area. There's not a way to just sort of do something with these numbers and right away see what it would take to double the area. Instead, we've got to go through a little bit of a process and actually double that area and then solve to find out how big of a side length it would take to make the area that we're looking for. Let me know if you have any questions on what we did there. At first glance, we think, make them 8x8, but that doesn't work. Yeah, I agree. There's more to that than it appears. At first glance, it's like, well, just make it 8x8. What's the big deal? And then we see, wait a minute, that didn't work. Okay, let's back up a bit here. And it's a little more of a process than it is something that we can just observe. We're going to say, all right, if this is the area I have, then this is the area I need. How do I get there? Well, because it's a square, these have to match, and that's what allows me to set up this equation that I can solve. Yeah, I think that's a challenging question. Now, it won't be a shock to you if you see something like that. Okay. Moving on to circles for a minute, we're going to talk about the arc length. What the arc length is it is a piece of a circle. So if we have a circle, then, and we're only interested in just a piece of that circle, let's say from here to here, just that piece of the circle right there. And we wouldn't put those hash marks on. Let's just look at it just literally as a piece of the circle. This is called an arc. Just a piece of the circle is called an arc. And what we're going to do is we're going to be able to figure out how long that arc is. What is the arc length? The abbreviation used for arc length is S. I'm not really sure why it's S. I'm going to make a note to myself to see if I can look that up. Why is arc length called S? But we use S for arc length. And so if we want to know how long that chunk of the circle is, we call that the arc length, and we'll use S to represent that. as you might have guessed, this is related to the circumference because the circumference would be all the way around the circle. And if we go all the way around the circle, that's 360 degrees. When we're looking at an arc, we're only going partially around the circle. So instead of going all the way, we're just going to here. And what we do when we look for arc length is we look at an angle that goes with that specific arc. The bigger the arc, the bigger the angle will be. In this case, we've got this arc right here, and the angle that goes with that arc is right here. And essentially what we're going to do is we're going to create a proportion using the idea that whatever the circumference is all the way around the circle corresponds to all 360 degrees. Whatever the length of my arc is corresponds to whatever my angle is. And that's the proportion that we're going to set up. Let's look at an example of finding the arc length. A circle has a radius of 7 inches. Rounded to the nearest hundredth, how long is the arc that is cut by a 25-degree angle? You don't have to draw a picture here, but I kind of like to. We've got this circle, and we're told that the radius is 7 inches. What we want to know is if I were to cut a 25-degree arc in here. So let's just say, I don't know, right here, I'm looking at this arc right here, and there's a 25-degree angle right there that makes that arc. What we're asked for is how long is that arc? What would the length of it be? And so here's how we set up a proportion to answer this question. What we're going to set up is the idea that, all right, all the way around this circle, the circumference would correspond to 360 degrees all the way around the circle. And the proportion that we're going to set up that goes with this then is, all right, S, this arc length that I'm looking for, is only 25 degrees around the circle. So the circumference is to 360 as the arc length is to 25. Hopefully the logic of that makes sense. If it doesn't, you let me know. And one of the things we're going to need to be able to answer this question then, if I want to use this proportion that I just set up, I'm going to need the circumference. All right, well, circumference is 2 times pi times the radius, and I was given the radius. So we can find the circumference here. Circumference is 2 times pi times the radius of 7 inches. So here our circumference is 2 times 3.14 times 7, 43.96. Now that I have the circumference, I can set up my proportion and solve for the arc length. I can take this 43.96 and put it in there and say all the way around the circle is 43.96 inches, and all the way around the circle is 360 degrees. My little piece of the circle corresponds with 25 degrees, and now I have a proportion that I can solve to find the arc length. To solve this, we'll cross multiply. 360 times S is whatever 43.96 times 25 is, 1099. And then the last thing we need to do in order to get S by itself is divide both sides by 360. If there's anything you see that you're unsure of, you're not sure where it came from, it's not making sense logically, please let me know. We'll divide that by 360. We were told to round to the nearest hundredth here, so I'll do that. We get an arc length of 3.05. Essentially what we're saying here, and it's good to kind of revisit that sometimes, is if the circumference all the way around the circle is 43.96, then this little slice right here, this arc that we look at with the 25-degree angle, has a length of 3.05. Any questions about that before I have you try one? Okay. A circle has a radius of 9 inches. Rounded to the nearest tenth, how long is the arc that's cut by a 35-degree angle? I'll set up a poll for this one and let you try it. You can see here that I've rounded to the nearest tenth. Those are the instructions in the problem also. And keep in mind here, there's a couple of stages to this problem. First, we need to find circumference. Then we need to find arc length using a proportion. We'll go another 30 seconds on this, and then we'll talk about it together. All right, let's see where we are. Unanimous, very good. That's excellent. I think arc length is a topic that tends to go really well, and that's what we've got here. You don't have to draw a circle, but I always like to. We have a circle with a radius of 9. We know we're going to need the circumference, and the circumference is going to be 2 times pi times the radius. And so here, that's going to be 2 times 3.14 times 9, or 56.52. Then the arc length, if it's 56.52 all the way around the circle, 360 degrees, then how far is it if we only go 35 degrees around the circle? And that's how we'll answer this one. We'll cross multiply. 360 times S is whatever 56.52 times 35 is, 1978.2. Last thing we'll need to do is divide by 360, and we wind up with S is 5.495. We were supposed to round to the nearest tenth, so we'll find the tenths place, look ones place to the right, that's 5 or bigger, so we'll round up to 5.5. The poll was unanimous, so I feel pretty good about where we are with regard to arc length. Any questions on that before we move on to talking about volume? Okay. Volume measures the capacity of an item. Just to sort of refresh your memory a little bit, we previously talked about perimeter, which was straight line distance, the length, one dimension. We would think about a fence for perimeter. how far around a figure, and it would be measured in inches, centimeters, feet, all raised to the first power because we're only talking about one dimension. Then we talked about area, which had two dimensions, length and width. And for this, we would think about like a carpet. How much space does it cover? And then because we're in two dimensions, length and width, our units would be in square units, square inches, square centimeters, square feet, what have you. Up next, we're going to talk about volume. And volume is about the capacity of an item. How much can you fit inside there? A lot of times, if you're going to buy a refrigerator, you'll see the cubic feet that can fit inside a refrigerator. For us, I think a nice simple example is just a box. How much stuff can you fit inside the box? And now we're not just going to be talking about two dimensions, we're going to be talking about three. Now we're going to have length, width, and height. And so we have three dimensions. And what that does is it means that we're going to have cubic units, cubic inches, cubic centimeters, cubic feet, whatever the units might be, they would be in cubic units when we're talking about volume. Let's take a look at an example of finding the volume. Volume of a box. Find the volume of a box with a length of 9 inches, a width of 4 inches, and a height of 2 inches. Again, you don't have to draw a picture, but you might want to. So let's see, we have a box with a length of 9, a width of 4. I won't do a great job with this width, I promise. And a height of 2. Yeah, I didn't make a width of enough. I'm gonna get rid of that box real quick. And I'm just gonna make it more of a rectangular looking box, and I'm gonna put labels on there and then let you know that one of the things that's true when we draw a picture is we are just making a sketch. And if it isn't exactly right with the dimensions, that's okay. Here the length is 9, the width is 4, and the height is 2. And you can kind of look at this and you can see that, well, if this is 2, this doesn't look much like 4. Yeah, you're right. I was just making a sketch to sort of organize all of my numbers. It doesn't have to be perfect in alignment with what the actual numbers are. And when you see a problem given, always trust what the numbers are, not what the picture looks like. Don't try to eyeball it. Trust the numbers that are on the picture to be accurate. Okay, if I want the volume of this box, I want you to think first about the idea that this down here would have an area. This bottom piece would have an area. And then essentially what we need to do is we need that area multiplied by however tall it is. That's how we're going to find the volume. How much stuff would fit in here? Well, if I take this area down here and I multiply by how tall it is, that'll give me the volume. So the volume is really just going to be length multiplied by width. That would give us the area of the bottom. Multiplied by the height gives us the volume of the box. Really easy formula to work with. Length times width times height. And so here the volume of this box would be 9 times 4 times 2, which is, let's see, 72. Because these are inches and we're looking for volume, it would be cubic inches. Your answer on a quiz or an exam would just be the 72. I do want you to know that it's cubic inches, but that won't be a part of the quiz or exam just because there's a lot of different ways to write cubic inches, and that would be a struggle to have Canvas grade correctly. Are there any questions on this before I have you try one? Probably not. My guess is that you're really comfortable with this one, so here goes. Oh, wait, I didn't make a poll for that one. I apologize. I thought I was gonna, but I didn't. If you have any questions on this, please let me know. I thought I had a poll for volume, but I don't. If you have any questions or concerns about finding the volume of a box, don't hesitate to ask those. Okay, now we'll talk surface area. Surface area of a box. What the surface area is basically how much material would it take to make this object, in this case, a box. We can find that by if we were to unfold it and lay it flat, and that's what this picture is over here. We've sort of, unfolded the box and laid it down flat so that we can look at it in 2 dimensions instead of looking at it in 3 dimensions. Because now we're looking for surface area, which is a 2-dimensional measurement. What we want to do here is build a formula for the surface area of this box. Okay, so if we look at the top of the box to start with, let's see, when I look at my box, what I've got here is I've got the length, the width, and the height. And so if I was to look at the top of this box, what is the area of the top? Well, that's the length times the width would be the top of the box. So this piece right here, the top of the box, would be the length multiplied by the width. What would the bottom be? What would the area of the bottom be? If the top is length times width, what's the bottom? The same. Thanks, Lorraine. That's length times width also. And you might be able to see that over here too. Length, and then imagine the width being on the bottom. So I have length times width twice. I'm going to start building my formula for the surface area of a box up here. I have length times width twice, so I'm going to just call that 2 times length times width. All right, so that takes care of the top and the bottom. Okay, well, how about the front and the back then? Let's look at the front and the back of this box. So the front here is the length multiplied by the height. That'll give me the front of the box. So the front here is length times height. And then I'm going to guess that you're with me on the idea that the back is the same as the front, and so that's also length times height. As I go to build my formula for the surface area of this box, the front was length times height, the back was length times height, so I have 2 length times height. I need to add that to what I had from before. So 2 times length times height gets added in. Some of you can probably already see where this is headed as far as what this is going to look like once we have our entire formula built. But now we need to do the right-hand side over here, and that's width times height. So the right-hand side is width times height. Similarly, the left is also going to be width times height. So I have 2 of those. So in building my formula, I need to add 2 times width times height also. Now we've taken care of all the sides, right? We did the top and bottom, we did the front and back, and now we just did the right and left. Those are all 6 sides. So our formula for the surface area of a box, while it's pretty lengthy, it's not a very hard one to work with. 2 times length times width plus 2 times length times height plus 2 times width times height. So as far as a box goes, we've got our formula for the volume of a box, length times width times height, the formula for the surface area of a box by adding up all 6 faces. Any questions about those formulas? And I remember now, I decided to join those 2 together, the volume and surface area of a box, and put those in one pole. Find the surface area and volume of a box with a length of 6, a width of 5, and the height of 3. And so what you're looking for here is surface area and volume of this box. I'll set up a poll for that. In the poll, surface area is listed first, volume is listed second. Really, this is about using those two formulas to find the surface area and volume of a box. I just want to make sure you're comfortable with those formulas and okay with using them correctly. We'll go another, I don't know, 30 seconds, kind of our standard. Let's go 30 seconds, and then we'll talk about this one. All right, let's see where we are. Okay, strong agreement, but not unanimous. Let's be careful as we go through this one with those two formulas. We were asked to find two different things here, surface area and volume. It doesn't matter which one you find first. I think because volume is a really simple formula, we'll start there. Let me know if you see something that you're unsure of or doesn't make sense. The volume of this box is length times width times height. So the volume of this box is going to be the length of 6 multiplied by the width of 5 multiplied by the height of 3. And so 6 times 5 times 3, 30 times 3, that's going to be 90. So our volume is going to be 90. Now, you don't have to include units, but I do want you to know that that's cubic inches because we're in 3 dimensions and we're looking at volume. So the volume will be 90 cubic inches. Surface area, a little more involved formula, where we've got 2 times length times width plus 2 times length times height plus 2 times width times height. And we're going to make sure we're careful when we plug everything in here. That's probably the biggest danger. And we'll have 2 times the length is 6, the width is 5, plus 2 times the length is 6, and the height is 3, plus 2 times the width is 5, and the height is 3. Essentially, what we're doing here is we're multiplying everything by everything else. We're doing length times width and height. We're doing width times length and height. And we're doing height times length and width. Or wait, width. So we're multiplying everything by everything else. Essentially, what we're looking at here are the different combinations that we could make with length, width, and height. At any rate, we'll go ahead and simplify this to get the surface area of this box. So let's see, 2 times 6 times 5, that's 30 times 2. 2 times 6 times 3, 12 times 3. And I'm rolling the dice, not using my calculator. Make sure you tell me if I have an arithmetic mistake. 2 times 5 is 10, times 3 is 30. Then we'll add all those together. 60 plus 36 plus 30 is 126. This would be square inches because we're talking about surface area. Your answer would just be the 126. So the surface area is 126 square inches. The volume is 90 cubic inches. One sort of definition I want to mention to you is fancy name for a box is a rectangular prism. So if you happen to see rectangular prism somewhere along the way, just fancy name for a box. Three-dimensional rectangle is kind of the idea there behind the rectangular prism. Any questions about surface area and volume of a box? All right, we've got another shape to look at. We're going to look at a cylinder. And just as a reminder, what a cylinder is we have something like that, maybe a soup can. It's an example I'm going to use later on, so I'm going to go ahead and start out with the soup can example now. And that's a cylinder. And we want the volume of this cylinder, which is how much will fit inside of it. Our philosophy here is going to be very similar to what we did with the rectangle. What's the area of this bottom? And then multiply that by the height. The way that I like to use this one is if I took a piece of bologna and I put it on the table, and then so that piece of bologna is the bottom, and then I stack a whole bunch of pieces of bologna up to the top. Now I have a cylinder, and if I wanted to hollow that out and see how much would fit inside of it, that would give me the volume of that cylinder. And so what we're looking for here is it's the area of the base. Well, the base of this is a circle. And the area of that circle that's at the base here, just the area of this bottom down here, that's a circle. The area is going to be pi times the radius squared. And then, okay, if that gives me the area of the bottom, and I need to multiply this by how tall it is, which we're going to call height. So the volume of a cylinder is going to be pi r squared multiplied by the height. And it's the area of that circle that's at the bottom multiplied by how tall it is, pi r squared h. So here, if we want to find the volume of a cylinder with a radius of 6 centimeters and a height of 15 centimeters, what we'll have then is the volume will be pi times the radius, which is 6, squared, times the height, which is 15. We have to be a little bit careful with order of operations here. What we look at and we can see is we have multiplication and we have an exponent. And that exponent has to be done first. So the first thing we're going to do is raise 6 to the second power. And we'll have 3.14 times 36 times 15. And now we just need to multiply all those together. So we'll have 3.14 times 36 times 15. So the volume of this cylinder would be 1,695.6. Let's see, these are centimeters, and it's volume, so they are cubic centimeters. Are there any questions about how we found that formula and how we use that formula before I have you try one where you find the volume of a cylinder? All right, here goes. Find the volume of a cylinder with a radius of 2 feet, a height of 7 feet. Round your answer to the nearest tenth. I'll set up a poll for this one for using the formula for finding the volume of a cylinder. And we'll go shorter on this one. I want to make sure I have enough time for that final quiz review. And we have one more idea after the volume of a cylinder that we'll take a look at. So we'll go pretty quick on the poll for this one. go another 15 seconds and then we'll do it together. All right, outstanding, unanimous. That's great news. All right, so let's go ahead and take a look at this one. The volume of a cylinder is pi r squared h. Here, that's going to be 3.14 times our radius, which is 2 feet, squared, multiplied by the height of 7 feet. So we've got 3.14 times 2 squared, which is 4, times 7. We'll multiply all that together. 3.14 times 4 times 7, 87.92. We were told to round to the nearest tenth, and round to the nearest tenth, that's 4 or lower, so we round this down. 87.9. This is volume and it's feet, so it would be cubic feet. Let me know if you have questions on that before we look at surface area of a cylinder. All right. The last idea in our semester is the surface area of a cylinder. Essentially, what we're doing with this cylinder is we're doing the same thing we did with that box. We're going to take the pieces, unfold it, lay it down flat. And what we've got on the bottom and the top of our cylinder are circles. So when we're looking for the surface area of this cylinder, what we're going to need is we're going to need the surface area of this circle that's on the bottom. And let's see, the area of a circle is pi r squared. And we also have this circle up here that also has an area of pi r squared. So we've got pi r squared on the top, and we've got pi r squared on the bottom. So we'll keep that in mind as we go to build our formula for the surface area of a cylinder. We've got pi r squared on the top, pi r squared on the bottom, so that's 2 pi r squareds. So we're multiplying 2 times pi r squared because we want to count this one and this one. So 2 of those. Now we've got to deal with this thing in the middle, which, you know, it's all the way around the circle. It's a little bit hard to imagine. What I want you to think of is if you were to take scissors and sort of cut a straight line and take the label off of the soup can. So if we were to cut it and take the label off and lay it down flat, what that label would make is a rectangle. And the rectangle would be as tall as the height of the cylinder. And then how far around would it be? Well, if we're going all the way around a circular object, then what we're talking about is the circumference. I don't know that I like to use W here, but the circumference is this length multiplied by the height would give us the area of that rectangle. So the circumference all the way around the circle, that's how long this is, multiplied by the height. Now we got to think about what that is then. So let's see. Circumference of a circle is 2 pi r. That's the circumference. And we need to multiply that by the height. Okay, so the area of this rectangle right here, the area of this rectangle is going to be 2 pi r multiplied by the height. If you're not sure where that came from, please let me know. Now I just need to say, okay, well, when I'm building this formula for the surface area of a cylinder, let's see, 2 pi r squared is that much. Now I need the area of this rectangle, which is 2 pi r h. So I need to add that on, 2 pi r h. Kind of a busy looking formula, the surface area of a cylinder. It's 2 pi r squared plus 2 pi r h. And it's essentially, we're adding up these components, give us the 2 pi r squared, and then that rectangle that would be the label is the 2 pi r h. Any questions about how we got this formula before I have you try one of these? Awesome. Here goes. Find the surface area of a cylinder that has a radius of 8 centimeters and a height of 18 centimeters. Last poll of the day, surface area of a cylinder. And like I said, this is the last new topic in Math 123 is the surface area of a cylinder. After this, we'll move on to a review for the final quiz that we'll do today, and then a review for exam 3 that we'll do on Tuesday of next week. So we've still got a little work to do today and on Tuesday, but this is the last new, this is the last new idea that we'll encounter. This formula is a little more formidable than the volume of a cylinder, so we don't have to go as fast on this one. And then after this, we'll look to start our review for the final quiz. Basically, I want to give you an idea of what to expect to see on there. Similar to the way we do our reviews for exams, it's not going to be the exact problems with the exact same numbers, but it'll give you an idea of what to expect on that final quiz so that you're not going into it, completely blind. In some ways, the review for the final quiz is a little bit of a review for the third exam because there will be some overlap in topics between what you see on the final quiz and what you see on exam 3. Let's go 15 more seconds on this one, and then we'll talk about it. If you want more time, let me know. And then we'll go from this one into our review for the final quiz. All right, let's see how we're doing on this one. Not unanimous, but agreement. I don't know if I would call it strong agreement. Let's go ahead and review this one a little bit. The volume of a cylinder is 2 pi r squared plus 2 pi r h. So there's kind of a lot going on. So you have to be careful when you plug in to this one. What we'll have here is 2 times pi times the radius squared plus 2 times pi times the radius times the height. Finally got to use the height. It was writing down an awful lot of numbers and never got to use the height. Finally got to do it there at the end. Just like before, we've got to do exponents before we multiply. So this will be 8 squared will be 64 plus 2 pi r h. And now I have multiplication and addition still to go. Multiplication goes first. So to the left of that plus sign, I've got 2 times 3.14 times 64, which is 401.92. Don't want to forget about what's on the right over there, which is 2 times 3.14 times 8 times 18, which is 904.32. And then the last thing we'll need to do is add those together and end up with 1,306.24. This is surface area of a cylinder. These are centimeters, so this would be square centimeters. That's how much material it would take to make this cylinder. Before we move on to the review for the final quiz, does anybody have questions about arc length, volume and surface area of a box, volume and surface area of a cylinder? All right, very good. So the last thing that we'll need to do to finish off our last week of new material is to do a little bit of a review for the final quiz, let you know what to expect to see on there. Here it goes. And just like always, you can ask questions whenever you have them. We won't do any polls in here, but please let me know if you have questions. Measures of central tendency. Might feel like a long time ago when we talked about statistics, but if we're asked to find the mean and the median of a data set, what we need to do is remember that the mean of a data set is what we get when we add them all up. We find the sum of the data points and divide by the number of data points. So the mean is what we get when we add them all up and divide by how many we have. So here our sum is going to be, let's see, that's 4 plus 6 plus 9 plus 3 plus 2 plus 3 plus 7. And we're going to divide by however many data points there are. Looks like 1, 2, 3, 4, 5, 6, 7. So we'll add that up. 4 plus 6 plus 9 plus 3 plus 2 plus 3 plus 7 is 34 divided by 7. 4.85714. We were told to round to the nearest hundredth, so we'll round that to the nearest hundredth and have a mean of 4.86. We were also asked to find the median. The median is the number in the middle, but before we find the median, it is critical that we take these data points that we've been given and arrange those from least to greatest. So let's see, that'll be 2, 3, 3, 4, 6, 7, 9. Now I have my data points arranged from least to greatest. I want the median, which is the middle number. I know I have 7 data points, so that's an odd number. So there will be one right in the middle. And then there are 6 other data points. 3 of those will be lower than the median. 3 of those will be higher than the median. Median's the one right in the middle. And so if I section that off, I've got the lower half, the upper half. The median is that 4 right there in the middle. So that is the median. Hopefully, this looks familiar and probably pretty comfortable. The final quiz includes stuff that are the big ideas. So it's things that I don't know, I expect you to do really well on. This is just more of a refresh your memory type of process that we're going through. Let me know if you have questions. The next thing we're going to talk about is weighted averages. And an example of that that's great for you guys is using overall grade. In Lacey's math class, homework is 25% of her grade. Quizzes count for 30% and exams count for 45%. Rounded to the nearest hundredth, what is her overall percentage in the class? The way that we're going to approach this is first, we're going to find the mean score for each of these categories. So the mean for homework, as far as Lacey goes, is going to be, we're going to add those up and divide by 4. So the mean score for homework will be 100 plus 80 plus 0 plus 85. 265 divided by 4 is 66.25. Be a little bit careful there. This 0 is one of her scores, so we count it. So when we find her mean homework score, that 0 is included, so we're dividing by 4. We're not throwing that out and dividing by 3. That is one of the scores. For quizzes, We've got 90, 72, and 90, and we'll divide that by 3. 90 plus 72 plus 90 is 252. Divided by 3 is 84. And then there's only one exam score, so we don't really need to calculate the mean. It's already kind of sitting there for us. And now once we have all those means, we're going to use these percentages to calculate the weighted average, because these aren't weighted equally. The homework counts the least, the exam counts the most. And so in order to find her overall percentage, I'll just call that OP, overall percentage, we're going to take 0.25 and multiply that by her homework average plus 0.30 and multiply by her quizzes average, and then 0.45 and multiply by her exam average. Now we just need to simplify that, and we'll have her overall percentage in the class. So the first thing we're going to do is we're going to multiply these together. 0.25 times 66.25 is 16.5625. We're going to do the same thing here with her quizzes and have 0.30 times 84 and get 25.2. And then finally, the exams, 0.45 times 85, 38.25. Please let me know if you're not sure where anything came from. What we're doing here to make this weighted average is that's where 25% of the grades comes from. That's how 30% of the grade that comes from, and that's where 45% of the grade comes from. Finally, the last thing we need to do is just add those up and then round correctly. And so we'll have 16.5625 plus 25.2 plus 38.25. And I've got 80.0125. And if we're going to round that to the nearest hundredth, we'll find the hundredths place, look one space to the right, that's 4 or lower. We'll round this down to 80.01. Nice work, Lacey, on getting that B. Just barely. Let me know if you have any questions on that. A lot of decimals we have to be careful with in there, but I don't think the concept is a very hard one. Find the mean of each category and then make sure you multiply the weight times that mean for each category before you add them up. All right. Counting permutations. There are 8 students in a class. How many ways can 3 of them be arranged for a photo? Really nice thing here is the word arrange lets us know that order matters. And order matters lets us know that we have a permutation. Formula for permutation is n factorial over n minus r factorial. And here we have a total of 8 students, and 3 are going to be in the photo. So this is the permutation of 8 things taken 3 at a time. You're welcome to use your NPR button, or you can do it by hand and have 8 factorial over 8 minus 3 factorial. That's 8 factorial over 5 factorial. Then I can rewrite 8 factorial as 8, 7, 6, 5, 4, 3, 2, 1, which cancels with my 5 factorial in the denominator. And really, I just have 8 times 7 times 6, or 336. How many ways could they be arranged for a photo? 336 ways. We're not going to write those down. That would be torture. But we can find that there are 336. Please let me know if you have questions on any of these as we go through them. Basic probability. There are 18 balls in an urn. 8 of them are red, 7 of them are white, and 3 of them are blue. One ball is selected at random. What's the probability that it is white? What this is about is the main idea about probability, which is successes over outcomes. We worked on some pretty complex probability questions. This is just a basic probability question. What's the probability it's white? Well, there's 18 balls in the urn, so there's 18 outcomes. What's the probability it's white? How many successes are there? Well, 7 of the balls are white. So I have 7 successes, 18 outcomes. So the probability that it's white is 7 out of 18. Again, let me know if you have any questions. We spent a lot of time on some pretty sophisticated probability questions. This is just a basic, straightforward successes over outcomes. Expected value. If we want the expected value of this spinner, what we'll do is we'll use the formula for expected value, which is we have results and probabilities. So, it's probability of outcome number 1 multiplied by whatever result number 1 might be, plus probability of result number 2 multiplied by whatever result number 2 might be. And then we do that until we get to the end. Good way to keep this organized is to set up a table of your results and the probabilities that go with them. And here are possible results. The thing that could possibly happen is a player could win 14, lose 3, or lose 9. And the probabilities that go with those. As we look at this spinner, we could cut it in half again. Okay, so the plus 14 is going to happen 1/4 of the time because it's 1/4 of the spinner. Don't overthink that. And losing 3 is going to happen 1/4 of the time because it's 1/4 of the spinner. And this losing 9 down here, that's half of the spinner. You could write it as 1/2, but you might remember if we do that, we're going to have to get a common denominator later on. So instead of calling that 1/2, I'm going to go ahead and call it 2/4 already, because if I do that, I already have my common denominator. So I'm not going to have to fool with that later on. Now we'll put these into the formula. The expected value will be, let's see, 1/4 of the time the player is going to win 14. 1/4 of the time the player is going to lose 3. And 2/4 of the time the player is going to lose 9. Now we just need to simplify this and we'll have our expected value. Little reminder, multiplying fractions times whole numbers will we can rewrite those whole numbers as fractions so that now we're just multiply numerators together, multiply denominators together. And here we have 1 times 14 over 4 times 1. 1 times -3, the negative is really important, over 4 times 1. 2 times -9 over 4 times 1. Since I have a common denominator, I can add these together. Let's see, 14 minus 3 minus 18, that's -7 over 4. And one thing that's true about expected values, we're going to write those as decimals. So we're going to go ahead and divide this and get -1.75. So the expected value for that spinner would be -1.75, meaning a player would lose $1.75 per spin. They can't lose $1.75 on one spin, but over the long term, if they play a whole bunch of times, they would expect to lose $1.75 per spin. Now we get to some geometry. Pythagorean theorem question. Find the missing leg of a right triangle with one leg 12 feet long and a hypotenuse of 22 feet. You don't have to draw a picture, but I always like to, if possible. One leg is 12. The hypotenuse is 22. Find the other leg. And here we're going to use Pythagorean theorem, which we've looked at pretty recently. That's leg squared plus leg squared is hypotenuse squared. And so here, that's going to be the thing I don't know, plus the other leg squared is the hypotenuse squared. And we just need to solve for x. So let's see, that's x squared plus 144 is equal to whatever 22 squared is, 484. Now, in order to get x by itself, I need to get x squared by itself. So looking at this left-hand side of the equation, I need to peel that onion from the outside in. I'm going to subtract 144 from both sides. On the left-hand side, those are going to cancel, leaving x squared. And on the right-hand side, I have 484 minus 144, or 340. And I'll admit, we're going through these review questions fairly quickly. Part of that is I want to make sure I get them all in before I run out of time. Part of that is these are all things you've seen before, and I'm hoping you're pretty comfortable with them because they are sort of big main ideas from the class. Last thing we need to do here to get x by itself is take the square root of the left and the square root of the right. On the left-hand side, those square roots, the square root and the squaring cancel each other out, leaving x. And on the right, we have square root of 340, which is 18.4390. We were told to round to the nearest hundredth. So we'll find the hundredths place, look one space to the right, it's 5 or bigger. So we'll round this up to 18.44. And that would be the length of the missing side. Now we get really recent. Similar figures. If I have these two figures and I'm told that they are similar, find BC and round your answer to the nearest tenth. So first thing I look for is corresponding parts to establish a relationship between these two figures. And I have 4 corresponds to this 3. And then what I'm looking for is BC over here, and the corresponding part would be here where this 9 is. So now I'm going to use those corresponding parts to set up a proportion. I'm going to say 4 is to 3 as 9 is to BC. There are other ways to set up the proportion and be correct. Just make sure that you are consistent with your logic. I went 4 is to 3, so the larger figure that's on the left is the number that's in the numerator. So when I set up my other proportion, 9 is to BC, the larger figure that's on the left, that's the number that's in my numerator. Another way to set this up that would make sense would be 4 is to 9 as 3 is to BC. That would be just fine if that way makes sense. If that way makes more sense to you, that's totally fine. Finishing this up, we'll cross multiply. 9 times 3 is 27, and that's 4 times BC. Then we'll divide both sides by 4 and have 6.75 is equal to BC. We were told to round to the nearest tenth, so we want to make sure we can identify place values and round. We'll find the tenths place, look one space to the right, that's 5 or bigger. So we'll round this to 6.8. Just one more to go. Dimensional analysis. Use the fact that 1 inch is 2.54 centimeters to convert 40 inches to meters. Now we're really recent, and if we want to convert something, we start with that thing. So we want to convert 40 inches, so we start with our 40 inches and set up our scaffolding. What I'm trying to get to is meters. And I've been given this unit fraction here that's 1 inch is 2.54 centimeters. So right now I have inches, so I need to use a unit fraction that has inches in it, and that's this one right here. And I'm going to put that 1 inch on the bottom and the 2.54 centimeters on the top, because I want these inches to cancel. Just by doing that, I've converted my inches into centimeters. Thing is, not quite done yet because I'm supposed to convert to meters. So I need to take these centimeters to meters. Valuable to know then that there are 100 centimeters in 1 meter. And with that in mind, I'll put my 100 centimeters on the bottom because I want these to cancel. I'll put my 1 meter on the top. I started out with inches, then I went to centimeters. Now the units that I have are meters. That's exactly what I'm after. So now I just need to multiply these numbers across the top. 40 times 2.54, and I get 101.6. Multiply these numbers across the bottom. 1 times 100, and I get 100. The only units I have left are meters. And the last thing I need to do then is divide 101.6 divided by 100, and I get 1.016 meters.